Okay, before we move on with a really useful thing, which is inheritance, what I thought we could do, take a little bit of a drink there. What I thought we could do is we could just play around with something called exceptions. Now, what this is the following. If we change this S, which is perfectly valid, let's just run it. Perfectly valid. We get a valid price coming back, no problem. If I change this to something which is invalid, like an X, run this, I get this nan for these prices here because they're not numbers, not a number. And that's because all the processing has gone wrong inside here, because, you know, you can see we've we need to be S, A and Q, and if we're not any of those, we're going to be 0, and if we're 0, then all of this is going to be horrible. So we end up with not numbers. Now that's ugly, and trying to debug that is going to be really ugly. So one thing we can do is we can wrap all of this inside a kind of safety blanket. And the safety blanket would look like this. We'd say, try to run this code. Do your best, you know. And if it goes wrong, figure out what went wrong. So what we can do is we can try to run that code with the X in it, which should go wrong. And if something goes wrong, then we're going to catch any errors that get thrown out. So that will generally be an integer, but it can be other things, but generally it's going to be an integer. So think of this as being a sandbox. This area here is a sandbox. We're going to try and run this code. There is an error, and this code is going to fail. So we'll catch the error. Now this code will specifically fail with the specific error here of not being S, A or Q. So we need to set that up as well, because it won't just, I mean, we can run this now. You know, we still get a problem because we catch it, so what? You know, it fails, so what? So what we're going to do is we're going to go into the H file, we're going to create a new error. Now you'd have a lot of these errors, but I'll just have one. I'll say Bond, Daniel Craig with blonde hair, before he became famous. Bond invalid bond type, it's got blonde hair. And we'll set that integer up to 99. So if this thing throws out a 99, we'll know that we weren't one of these things, A, S, or Q. So let's, I think that's probably all we need to do in the H file. Let's go to bond.c++. So here, when we get the type coming in, we're going to do a check. So what we'll do is we'll say if the type coming in is not equal to one of these three things, that, or that. If the thing coming in is not equal to bond, let's go for the annual type first. That makes sense. I've got too many brackets now. It's gone crazy. Okay. And type is not equal to the semi-annual, if we can find it, there it is. And type is not equal to the final one, the quarterly one. Then what we're going to do is throw that error. So bond invalid bond type. Now the program, this bit of code will just stop. None of this will happen. The code will just throw out now. Now we could wrap this inside catch and exception kind of constructions, but we're not going to. We're just going to throw this error. You should be able to see that if I put an error here saying a message saying got here, just as a kind of debug message, you should see that if we call this now with an X, that we don't get that message, because we never reach that far. Now we don't do anything else either, but What's going to happen is this is going to try to execute. We send in the X. That gets read here. We then check it. Is an X equal to an A? No. Is an X equal to an S? No. Is an X equal to a Q? No. Throw the error. We never reach this line. It's all over. D-Day has finished. We've been thrown off the beaches. We come back to this program. We don't even get to this line. So we finish basically there. We finish here. That's it. The error comes out, and then we can catch that error. So down here, what I'd do is I could put something here. You can see if I just put any old thing here, we will get that to come out. So we will get an XXX. Oh, expected something else. Oh, yeah, sorry, I missed the doodahs, haven't I? Should get the X, there we are. But now we want a more of a meaningful message than that. So we do get that 99 coming in there. So what we'll do is we'll say bond creation failed, error, and we'll type out the error, and the error is coming to us in that variable there. And then we'd have half a clue as to what to do next. So that should come out with that error. Yeah, there we are, error 99. Super. Now, if we notice we are, it gets thrown out here. It misses all this code out. That's all missed. Come into here, and then we print out that message, and then we move on. So it's like a sandbox, like a safe. It's like walking on a tightrope with a safety harness on, and this, or a safety net. This is the safety net, and we get meaningful. We get meaningful errors, and if there are any other errors, negative interest rates or anything else, we can chuck out. We can throw out. Sorry, we can throw out different messages. So that's very, very handy. Anyway, I just thought we'd put that there as a little interlude before we get to inheritance. Oh, one other thing you'll see, I never use this, but a lot of people do, is they just put an ellipse there. Now, when they put an ellipse, you can't have this error message with a number because there's no error message coming in. It's just there was an error. So the only thing I can do there is this. That's fine. So do look out for that. I don't like it. I much prefer it if somebody gives me something meaningful I can track back later. So I will typically have an error number. You can output other things as well if you're feeling fruity. But I'll let you look that up. I always use int anyway, so I'm not telling you. I'm not missing out telling you anything. I always use ints. I always use errors so that I know and I can track back and find out where is it? Exactly where that error got thrown. I know this is 99, so I check my type and I come back to the main program and go, it's an X, no good. Just turn it back into a proper thing, semi-annual. Bang. Now you can get the same thing divided by zeros, negative interest rates, all the usual things which should be impossible and which could cause your code to fail. Try them in the safety harness. If anything goes wrong, throw out an error, catch the error, print a meaningful error message, and Bob is your uncle. Okay, I think that is enough. See you next time.